These are the ideal filter frequency responses for low pass filter, high pass filter, band pass filter, and band stop filter. The frequency response comprise of a pass band which is flat with no ripples since it's an ideal filter response, and the magnitude is unity, and in the stop band attenuation provided is 100% and therefore the magnitude is 0. So for high pass filter, this portion is a stop band and this one is the pass band. And in case of band pass filter, omega A and omega B are the two cutoff frequencies. Inside these cutoff frequencies is a pass band. Outside these frequencies are the stop bands. And for the band stop filter, in between omega A and omega B is the stop band of the filter, and beyond omega A and omega B are the pass bands of the band stop filters. So when we start with the digital filter design in general for both FIR and IIR cases, it's important to understand what exactly we are doing in the filter design. So in the development of digital filter, we are actually finding the filter coefficients h of n and the transfer function of that filter in terms of h of z, where the digital filter specifications required to be followed are the magnitude response of the filter and the transition band which is specified between pass band and stop band. And the magnitude response will contain the pass band and stop band tolerances along with the cutoff frequency values. So herewith is the comparison between an ideal filter frequency response and a practical frequency response. Ideal filter will have no ripples in the pass band and the magnitude will be maintained constant at unity in the pass band, and in the stop band the magnitude will be 0, and again there will not be any ripples in the stop band in case of ideal filter. Whereas in case of the practical filters, we see that there are ripples in the pass band, there are ripples in the stop band as well. And then there is also a transition band wherein the roll-off of the magnitude takes place from pass band to the stop band. In this case, 1 plus del P and 1 minus del P indicates the pass band magnitude tolerance, that is the deviation from mean value to the max value. Similarly, del of S represents the stop band ripple, and the frequency range lies in between 0 to pi. So herewith is the basic block diagram for a real-time digital filter. It is similar to the basic block diagram of a digital signal processing system. So this digital filter makes use of an analog input, then a pre-filter in order to band limit, followed by that an ADC block, a digital processor inside which there can be a software form or a hardware form wherein the digital filters mathematical algorithm will be implemented. The output of digital filter, the digital processor will now be a filtered digital output which is passed on to the DAC followed by that it is given to the interpolation filter, and thus we get the better quality digital output as a real-time digital filter implementation. So when we implement the digital filters in hardware form, it makes use of a delay element, adder block, and multiplier block. So this is an example of a FIR digital filter. So it is basically a averaging system, and in this averaging system we could note that there is only a feed forward path, and input is passed to this feed forward path, and the three terms are added together, that is original input, then one sample which is in advance, and the next sample which is a previous sample. So the three samples are added together, and a multiplier of 1 by 3 as in a hardware block, a multiplier block, it will multiply to this addition so as to get the averaged output. And this is how the noise will get averaged, the noise will get suppressed. Another example is IIR digital filter block diagram representation. So it's a first order IIR filter representation. Being IIR, it's a recursive filter, and hence the present output depend on present input as one sample, and another sample is y of n minus 1 into a. So y of n minus 1 is the past output sample. So thus this becomes a feedback system. A is the filter coefficient presented here. So this is a block diagram representation of IIR digital filter. So at the end of this session, try to answer these review questions as: what are the types of digital filter? What is meant by the term FIR and IIR? Write down the difference equation form and transfer function form for FIR and IIR filters. Compare between FIR and IIR filters. Why FIR filters are considered to be inherently stable? What are the building blocks in real-time digital filter? And try to draw the block diagram for first order non-recursive and recursive filter, that is FIR and IIR